Hello everyone! Have a nice day! Okay, so good morning. I hope you had your meal already. So by the way, I am Teacher Diana and I will be talking to you a lot of things about science. Okay, so I hope that you are ready. And if you're watching this video, please take a screenshot and send it to our group chat because it will serve as your attendance. So before we start, let's first set our classroom rules. Number 1, you should not be late. You should be on time for classes. Our class starts at 8:30 and ends at 9:30. It means that you only have 1 hour to listen to the teacher and you only have 1 hour to do the activity. Number 2, you have to dress appropriately because this is still a classroom. That's why you have to respect the teacher and also your classmates. Next, you have to choose your own study space and your study space must be conducive for learning. Number 4, there should be no gaming for classes, okay, or during classes because gaming distracts you. And if it distracts you, then you don't have the focus already to discuss or to solve the different problems intended for you to answer. And then you have to come prepared. You have to bring your calculators, your paper, and then your pencil. Okay, so for you to be able to answer and actively participate in the class discussion. And then you have to respectfully ask your teacher for queries. If you have any questions, just send a message to your teacher, okay, or to me, and then I will answer that query. And then next, you have to have fun because learning is always fun. And then you have to respect and encourage each other. So those are the different classroom rules that is set for you. So now let's go to the different most essential learning competencies and the different objectives that we need to follow for this lesson. Okay, number 1, okay, for your MELC, you have to perform activities to demonstrate the conservation of mechanical energy. And then for your objectives, okay, you have to trace and explain the energy transformation in various activities. Okay, number 2, you have to perform activities to demonstrate the conservation of mechanical energy. And then number 3, you have to ascertain the total mechanical energy remains during the process of during any process, okay, involving potential, kinetic, and thermal energy. Okay, so before we start the lesson, let us have an activity or a game, and this is called Energy Skate Park. Before we proceed to the discussion, so let's have an activity or a game, and this game can be taken from the PhET simulations. So the PhET simulation is a laboratory simulation wherein you can manipulate or you can use for you to visualize what really happens when you skate in a motion. Okay, so when you skate and then what happens to your energy. Okay, so if you're going to look at the game, so if you can see here that the boy is skating. So in the PhET simulation, it can be seen the potential and kinetic energy. So you can also create a bar graph or you can also generate a bar graph from it. Kaya you can grade it for you to look at the height. And then you can take also the speed. Okay, but let's focus first on the different pie graph and then the bar graph wherein it was indicated here the potential and kinetic energy of the skater. So as you can see, as the skater goes up, okay, let's pause it. As the skater goes up, what type or what specific type of energy is increased? Okay, very good. The skater goes up. The specific type of energy increased is the potential energy. What about if the skater goes down? Okay, as the skater goes down, the specific energy that increased is the kinetic energy. Very good. So, it happens, okay, in a constant motion and it does not stop. But if the skater is already done skating and it stopped, okay, so once it goes down, what you can see is an orange icon or an orange symbol which symbolizes that the skater is emitting now a thermal energy. But if you can see, the total energy here is just the same like the thermal and then the kinetic. So it means that energy is not wasted here because the total energy did not go down or is not decreased. Okay? But the total energy remains the same. It means that the kinetic energy or the potential energy is neither destroyed nor wasted. Okay. So with this, what specific rule can you show or can you infer from this? Okay. So what specific rule? O kaya law? Okay. So very good. That is the law of conservation of mechanical energy. Okay. The law of conservation of mechanical energy means that energy is neither created nor destroyed. So it can only be transformed from one form to another. Okay? So it means that your kinetic energy is not wasted or it did not go anywhere, and your potential energy did not go anywhere too. But it is only transformed or it is only converted into heat energy. Like when we run, okay, when we run, we used to release kinetic energy. Then when we stop running, we have two energies now. We have potential energy and your body is tired. That's why you also emit or you also release heat or thermal energy. So that is the law of conservation of mechanical energy. Okay, come again. What's the law of conservation of mechanical energy? Okay, the law of conservation of energy states that energy is neither created nor destroyed. Ibig sabihin, hindi po siya nagagawa and it is not also destroyed. And it can only be transformed from one form to another. Okay, so now that you have an idea about the law of conservation of energy, let us try to study these images. Okay, so what can you see or what is the man doing in the picture? Okay, very good. The man is eating. Okay, so the man is eating and after he eats, what will the man do? Okay, the man will go to the gymnasium. Okay, or rather to the gym because the man will work out. So what do you think will happen to the food that the man ate? Alright, very good. So the food that the man ate will be converted to energy. And this energy will be used to work out and to perform activities, hard activities like going to the gym. Alright, let's go to the next one. So we have two types of energy like what we have discussed a while back. If you can remember on the energy skate park, that if the skater goes up, okay, the motion becomes slower. That's why when the motion becomes slower, it is it's gaining potential energy. But when the motion goes down, the motion becomes faster, and if it becomes faster, then that means that the skater is gaining kinetic energy. So we have now potential energy. So class, potential energy, like we have discussed before, okay, it is an energy at rest. It means if it's an energy at rest, then this energy is due to arrangements of the parts, the composition, the location, and also the structure. It means if it's at rest, then it means that the motion is on 0 meters per second. So your speed or your velocity is 0 meters per second. Alright, let's go to kinetic energy. So that is for our potential energy. Now let's go to kinetic energy. Okay, kinetic energy now, class, is an energy in motion. So this is an energy that is exerted or that is possessed in moving matter. So it means we have different forms of energy. Okay, so number 1 is motion. Next, radiant energy. What is the other term for radiant energy again? It's very good. We have solar energy. So that's the other term for the radiant energy. So ibig sabihin, if we have solar energy, then that can be considered as your kinetic energy. And then we also have sound energy. Why is sound considered kinetic energy? Well, in fact, you cannot see sound, right? But you can hear it. So why is sound again considered a kinetic energy? Okay, sound is considered a kinetic energy because if for example we have this barrier. Okay, so when this barrier or when these strings were moved, okay, it creates disturbances. Okay, and these disturbances are what we call the waves. And these waves should vibrate. Okay, there are vibrations. Okay, when there are vibrations, then it means that there is a sound. Okay, also heat energy. Remember that when an object is heated, then that object is subjected to contraction and expansion. Okay, and we also have waves. Okay, so like what I said a while back, waves are disturbances. So that's for our kinetic energy. Okay, now let's go to the next part. So, what can you see? Or what can you say about the picture? Okay. So, if you can see, here, the man is moving. Okay. And as the biker goes up, the biker is releasing effort. Okay. It's releasing effort. It means that the biker is absorbing a lot of energy for it to release, okay, for it to release a lot of force, a lot of effort. Okay, so that is kinetic energy. Okay, so once the biker reached the top, okay, the biker can now rest. That's why when it is on the top, if you can remember projectile motion, okay, projectile motion, can you describe the velocity at the maximum height? Okay, the velocity of the y component, okay, at the maximum height. Okay, di ba? The velocity of the maximum component ng y component at the maximum height is always equal to 0 meters per second. Because when it is at the top, it means that the velocity is okay, o kaya the object is already at rest. Okay? And then once it goes down, the energy that was absorbed a while back was now released. And then the biker can easily go down, and the biker will not exert a lot of force to go down because it is also being pulled by the gravity. Alright, So now, let's move on to the next part of our topic. So, for us to find the total mechanical energy, okay, we are going to use or to follow the following formulas. So, we have here mechanical energy 1 is always equal to the mechanical energy 2 and then mechanical energy 3. Or, we can also use this formula, potential energy 1 plus kinetic energy 1 is equal to potential energy 2 plus kinetic energy 2, and then potential energy 3 is always equal, okay, to the prod or to the sum of the first two potential and kinetic energies. All right, so that's our formula in getting the total mechanical energy. So now, for us to test if this is true to all, okay, let's try to answer the following problem. Okay, let's consider a 1 gram stone. Okay, it should be 1 kilogram rather. 1 kilogram stone drop on top of a hill and reach the ground after 3 seconds. From your concept of free fall, the height of the hill can be computed using the formula. Okay, the formula for getting the height is 1/2 AGT squared. Okay, so now let's try to compute the height of the hill using this formula. So if you can see, let's write the given. What are the given values? We have your time, 3 seconds, and then the mass is 1 kilogram, and then the gravity. What's gravity? Gravity is constant, like I say. Gravity's value is 9.8 meters per second squared. And then, okay, so that is our given. Now, let's try to substitute the given in the formula. So, in getting the height, 1/2. So, for the acceleration, since that is free fall and the motion is going down, it means that the acceleration is negligible. So, the acceleration, if it goes down, it will always be negligible. Okay? So, we don't include a value for the acceleration in free fall. Okay, so we have, what is our gravity? Acceleration due to gravity is 9.8 meters per second squared. And then we have our time squared. Our time is 3 seconds squared. So now let's compute for the height. We have 1/2. This is 9.8 times 3. That is 88.2 meters per second squared times second squared. Okay. So, let's cancel the unit second squared for us to get the unit meters. So, we have height is equal to 1/2 times 88.2. That is 44.1 meters. So, this is now the height of this is the height of the hill. Next, okay, now if we get the height of the hill, then what should we compute next? Okay, so now let's try to compute for the potential, the kinetic energy, and then your total or the total mechanical energy. So, let's take our height a while back. Our height is 44.1 meters. So, the formula in getting the potential energy is mass times gravity times height. Wherein, what's our mass? Okay. Our mass is 1 kilogram. And then our gravity is 9.8 meters per second squared, and then our height is 44.1 meters. Okay. So this potential energy is taken from if your time is 0 seconds, which means that the ball is about to be, or the stone is about to be dropped. It means that the stone is still in someone's hand, or it's still following the potential energy. Okay, so now let's compute this one. If you have your calculator, you can just easily type it in your calculator. So you have 1 times 9.8 times 44.1. And your answer will be, your potential energy will now be 432.18, and this should be in, okay, kilograms meters squared per second squared, or it can be also equal to 432.18 joules. Okay, so joules is the unit for energy. So that is joules. Okay, so now let's compute kinetic energy when the time is 0. So 0 seconds. So what's our formula for the kinetic energy? We have 1/2 mv squared. Okay, so we have a mass. But what do you think? If the stone is about to be dropped, then is there a velocity? Okay, you have a point. Okay, so because the stone is about to be dropped, it means it's still not following, or it doesn't follow a path, right? So the velocity is still 0. So 1/2, our mass is 1 kilogram, and then our velocity is 0. Then therefore, your kinetic energy at time 0 is equal to 0. Okay. So now let's compute for the total mechanical energy. So it can be taken from PE plus KE. What's our KE? 0. And then our P, it's 432.18 joules. So what's our MET now? Our MET is, total mechanical energy is 432.18 joules. So that is our total mechanical energy. Okay, so now let's compute for the time is equal to 1 seconds. Okay, so let's compute for the potential energy if the time is 1 second, and then the kinetic energy if your time is 1 second. Okay, so are you ready? Okay, very good. So for us to do that, we need to get the height of the stone after 1 second. Okay, so let's try to let's draw. If this is a hill, okay, if that's your hill, this is your hill. If your stone is here and the height of the hill is 44.1, after 1 second, what should be the height of the stone? Okay, or what should be your height now? Will it decrease or will it increase? Since it is free fall, then provided that the height will decrease because, okay, it's going down, or it is following the force of the gravity. So let's say this is the point after 1 second. So now let's try to compute the height after 1 second. So we're still going to use the formula 1/2 gt squared, wherein 1/2 of the 9.8 meters per second squared times what's our time? 1 second squared. Okay, any number, okay, raised to 2 is equal to the sum of the two numbers. So what should we do here? We have 1 times 1 is equal to, okay, 1 times 1 is equal to 1, and then 1/2 9.8. 1/2 of 9.8, it's 4.9 meters per second squared times 1 second squared. Okay, let's cancel. Our unit now for height is 4.9 meters per second. Okay, meters only. Okay. So that is our unit for the height, or for the height at 1 second. So let's compute now for the potential energy. So our potential energy is mass 1 kilogram times gravitational acceleration due to gravity, which is 9.8 meters per second squared. And then what do you think will be the height? Okay, so if this is 4.9, then you should deduct 44.1 minus 4.9, okay, meters. And this will be your new height. Okay, so 44.1 minus 4.9, this will give us 39.2. Okay, and then 9.8 times 39.2, that is 384.16. So this is now, okay, joules. That is now our potential energy at 1 second. Now let's compute for the kinetic energy. So how do we solve kinetic energy? 1/2 mv squared. Okay. So what do you think will be our velocity now? Okay. So our potential energy at 1 second is 1/2 times 1 kilogram. And then what is our velocity? That would be, okay, wait, let's compute. So our mv squared now is 9.8 meters per second. Okay, so we don't need to compute anymore because this is just our acceleration due to gravity. 9.8 meters per second. So this value will give us 48.02 joules or kilograms meters squared second squared. So this is now our potential and kinetic energy. Okay. So now let's compute for our MET. So our MET, sorry. So let's erase. Our MET now is equal to 384, okay, 0.16 joules plus 432.18 joules. So these are the values that we have taken or we have computed a while back. So the total value is, wait. Okay, so let's erase first because it should not be okay. So again, our MET is PE plus KE, which means our PE is 384.16 and our KE is 48.02 joules. So in total, we would get 432.18. Okay. So did we get the same MET a while back? Yes. Okay. So like our answer a while back on the MET on 0 second. So it's still 432.18 joules. It means that the energy is conserved. It means that there are no wasted energy despite of the fact that the height changed or kaya the height changes. Okay? Because a while back, our KA is 0, but now our KA is 48.02. So if you can observe, there is still a conservation of energy because a while back, our potential energy is 432.18 and now our potential energy decreased already. Okay. So that is for the computation on the conservation of mechanical energy. Okay, so now let's try to solve this. Okay. So you're going to identify what type of energy is absorbed and what type of energy is released using the different devices. Okay. So if we have a solar panel, then what do you think the type of energy will come in or will be absorbed? Okay, from the word solar, the type of energy is, okay, we have radiant energy. O kaya, you can also call it solar energy. Okay, so when the solar panel absorbs solar energy, this solar energy will be converted now into electrical energy. That's why it is cheaper to use solar energy or kaya solar panels, okay? Especially if you have heavy equipments at home like air conditioners, refrigerator, and other equipments that require a lot of cost of energy. Okay, number 2, we have chemical energy, okay? And this chemical energy is used in electric fan. So what type of energy is being transferred or transported? Okay. So we have electrical energy. Okay. So another, we have radio here. So what do you think is the type of energy that is absorbed by radios? Okay. What? Alright. We have electrical energy because radio, especially nowadays, cannot function without electricity. And then the type of energy that is released is a sound energy. Okay, also the same with microphone. Okay, and it also releases sound energy. And in television, it uses electrical, but it releases 2 types. So it can either be sound energy or light energy. Since television can emit light and can also enable us to view moving objects or motion pictures. Okay, so these are our electrical or this shows the conservation of mechanical energy, and this can also be found in your module. So if you want, you can answer in the explore part. Okay, let's go to the next one. Now let's try to solve these problems because this problem will cost us, I'll give you additional 2 points for each problem if you get it, if you get the correct answer. So is that okay with you? Okay, so now let's try to answer. A 2-kilogram toy car moves along a frictionless surface with a uniform speed of 6 meters per second. What is its kinetic energy? So we are now finding, or we're now looking at the kinetic energy of the toy car. So how do we do that? First, we need to get the kinetic energy. We need to give the given. What's our formula for kinetic energy once again? It's 1/2 mv squared. So what are the given? Mass, we have 2 kilograms. And then the velocity, which is 6 meters per second. So how should we do this? 1/2, substitute the given 2 kilograms times 6 meters per second. Okay, so what is our formula here? What's our answer here? Okay, 2 times 6 divided by 2, we have 6 joules. So the kinetic energy now is 6 joules. Okay, so this is our answer for number 1. So if you get the answer, additional 2 points for you. Okay, next question. Budoy, a junior high school student, lifts a 3-kilogram book from the floor into a cabinet of 2 meters high. With reference to the floor, how much potential energy does the boy acquired? Okay, so what is asked? We need to get the potential energy, which has the formula mgh. Okay, let's write the given. The given is m, mass 3 kilograms. Gravity, acceleration due to gravity is 9.8 meters per second squared. And then, height will be 2 meters. Okay, so now, let's substitute the given. We have here 3 kilograms times 9.8 meters per second times 2 meters. Okay, so let's get the answer. 3 times 9.8 times 2. So we have 58.8 kilograms meters per second or joules. Okay. So we have joules as our unit. Okay. Now let's move to the next problem. So if by the way, if you get this, be honest ha, that's 2 points for you. Okay. Next, we go to the next one. A 10-gram egg is dropped at a building for 10 seconds. Determine the height and the total mechanical energy. Okay, so now this is only similar to the first problem. Okay, so we have given 10-gram egg, and then time is 10 seconds, and then your acceleration due to gravity is 9.8 meters per second squared. Okay. So what's our height? Let's solve for the height of the building. We have 1/2 gravity, it's 9.8 meters per second squared times our time squared. Okay, second squared. So 9.8 times 10 times 100, because 10 squared is equal to 100. Okay, so 9.8 times 100 divided by 2. Okay, so 980 divided by 2. We have for our height, we will be having 490 meters. Okay, so now let's compute for the potential energy. So how should we do that? Easy, right? Potential energy at time is 0 is at time is 0, we have our mass 10 grams. Sorry. We have our mass 10 grams, and then acceleration due to gravity, and then we have our height, which is 490 meters. So we have times 10 times 9.8. So we will be having 48,020 joules. So this is now our potential energy. So now let's solve for the kinetic energy. So our kinetic energy is at time 0. This is at time 0. 1/2 mv squared. Okay, we have 1/2 10 grams And then, V squared is 0 muna siya. Meters per second. By the way, we need to convert it. So, 10 divided by 1,000, it's 0.01. 0.01 kilograms. Okay. So, times 9.8 times 490, that is 48.02. We have 48.02 joules. Okay, and here we have 0.01 kilograms. So, still, our kinetic energy is 0 meters per second. Okay, so that is how we are going to compute for the kinetic energy. Okay, so that's it. Do you have any questions? Alright, so I bet that you don't have any question. So for your activity, please answer the 15 item test on the gauge part, and then please read your module 5 in science, and that is all about heat and work. Okay, so thank you everyone. Okay, that's right. Thank you. Goodbye.